Welcome back, welcome back, welcome back to Geometry, Chapter 9, Section 4 in this book. But you don't have to have this book to learn about special right triangles. Now, actually, I'm fine if you don't learn about special right triangles. Yes, it's true. Let me tell you what the whole thing is about this, okay? A long time ago, where we're going is to learn trig. I already told you that in another one. And a long time ago, they didn't have these wonderful calculators. They didn't even have LAMO calculators that could do trig. So but they still wanted the kids to do trig, and the way you would do it is originally you would use books and you would have to look up the values in these giant books. I remember when I went to college in the 80s, seeing the books in the chemistry room and there were these huge books, and I don't know, I never had to use the books. My whole life I've had these calculators. But I didn't know if you had to use all those books or if just one book had all the answers in it. I don't know, because I didn't know if it was a classroom set or like one set of encyclopedias. I don't know how to use them. And before me, the people would use a thing called a slide ruler. I don't know how to use them. You slide little things up and back and somehow it tells you the trig things. But you're going to use your calculator. But before we had the calculator, professors would want to give problems that were trig problems, and they could do it with the kids not knowing the trig if they memorized special triangles. So what makes them special? Oh, ain't that special? I just hear my aunt saying that about my cousin. Ain't that special? I'm from Georgia. Anyway, so they made the special ones, the 45, 45, 90, and the 30, 60, 90, and you would memorize these values. There's also a trig little table you would memorize with these because they were the special ones. So what this means is if you have a right triangle where one corner is 90 and the other two are 45, then there is a relationship. The two legs will be the same because it's isosceles, and the hypotenuse will be the square root of 2 times x. And people used to memorize this back in the dark ages of the 70s, okay? The same thing with this one. If one corner is 90, the other one 60, the other one will be 30. So it's a 30, 60, 90. The short leg will be x, the medium leg will be square root of 3 times x, and the hypotenuse will be 2 times x. So you can get the answers to this easily, especially with trig. Okay, but you could do it with the Pythagorean theorem also. You could know these relationships, and you could know more about the triangle than you would normally. Now, what we do now is we do trig, and we use our calculators, which you're going to be able to do very, very soon. This chapter even. All right, so they have a problem where they use the special triangles, and they do several of them in the book. This is what I want you to do. Pretend this doesn't exist, because I have found that if you teach kids too many ways to do stuff, they get to the big test, panic, and don't know how to do any of it. I would rather you do it the regular way all the time, or if you can't do it the regular way, you're going to do it using trig. And we're not going to mess with the special triangles because it is not the 70s anymore. I loved the 70s when I was there as a little kid, but we're done with that. All right, so I'm going to show you how to do these problems the regular way. No special triangle needed. So we have a 45, 45, 90. If this one's 45, we know that one's 45, and we could use the special triangle method. You can see it in the book if you're curious, or we could just do it regular. These are the legs, that's the hypotenuse. A squared plus b squared is c squared. 9 plus 9 is x squared. 18 is x squared. We don't want x squared, we want x, so we do the opposite. We take the square root of both sides. What's the square root of 18? Well, 18 is made out of 3 times 6, and 6 is made out of 3 times 2. There's our twins. One gets dissolved in acid, the other one gets out of jail, and one stays in jail. So x is equal to 3 times the square root of 2. If you don't know how to do square root, go back and watch the other video. And you can also go back and watch the videos from Algebra 1. And There, I explain it slower. Okay, I expect you kind of know this now. All right, so the other thing is, I wrote on the board when I went through this the first time, but hopefully it'll still make sense. I'll point it out slower to you. But, okay, so your book uses the special triangles. I say don't use the special triangles. You can do it another way. And that special triangle is just something else for you to remember, that you don't need cluttering up your brain. You've got your calculator, you're going to learn trig. You do not need special triangles in your life. Alright, so here is another problem they did with this special triangle. I'm going to show you how to do it the regular way. It's x and x, so we know it is isosceles, and this one is a right angle, so we know it's 45, 45, 90. But we are told that the longest side, the hypotenuse, is 5. So we put it into our regular way formula for Pythagorean theorem. A squared plus b squared is c squared. So x squared plus x squared is 5 squared. Looks a little funky, but we can handle that, because now x squared plus x squared is, I erased that before, is 2x squared. And 2x squared, 5 squared is 25, okay? And so 2x squared equals 25. Y is x on a line. It's being multiplied by 2, so we divide both sides by 2. That's where that 2 came from. And then those cancel out and go away. Y is x on a line. It's squared, so we do the opposite. We square root of what we do to one side. That looks pretty terrible. We do to the other, and that's how we got here to the 25, square root of 25 over 2. And so if you do this, 25 can be square rooted, and 5 gets out from the radical, because 25 is made out of 5 times 5. There's the twins. But 2 doesn't have any twins, so the answer is 5 over the square root of 2. But this is considered bad math etiquette. Oh, look how rude. It has a radical in the denominator. I hope you're very offended by that 2 radical in the denominator. Now, what my college-age sons tell me is college professors don't care about that anymore. That they don't think it's rude, and that is the answer in college. But your book is a high school book that's following the old etiquette. So what you're supposed to do is multiply the numerator and denominator by the offending radical. Okay? And square root of 2 times square root of 2 is 2. So no more offending radical in the denominator. And then in the numerator is 5 times the square root of 2, which is not considered rude. It's fine in the numerator. It's just considered very, very bad math etiquette in the denominator. I don't care. If you wrote that on the test, I'd give you credit. But if you look in the back of your book, you won't see that, you'll see that, and that confuses kids. Alright, can we do this one the regular way? It's T on this side, S on that side, 5 on this side, and it's a 30, 60, 90 triangle. No, we can't. Do we care? No. In just a skinny minute, I'm going to teach you how to do this with trig. And we will just solve everything out of that triangle. We're going to just solve. Okay? So, then they did this one. It's a yield sign. It is same on all sides. So it is an equilateral triangle. It's 36 on each side. And so if you are going to get its area, you need its height. And half of 36 is 18. So we have a right triangle right here. The hypotenuse is 36. One leg is 18. And we need the height, the other leg. So a squared plus b squared is c squared. 36 is the hypotenuse, it's the c squared. X squared plus 18 squared equals 36 squared. 18 squared is 324. 36 squared is 1296. We subtract 324 from both sides to get x by itself. We have x squared equals 1296 minus 324, which is 972. Y is x on a line, it is being squared, so we do the opposite. We square root what we do to one side, we do to the other. And so we do a factor tree to see who gets out of jail, who stays in, and who gets dissolved in acid. 972 is 18 times 54. 18 is 2 times 9. 54 is 9 times 6, and 6 is 2 times 3. And I already taught this once, and that's why it's all marked up. So here are twins, 9 times 9. This one gets out, that one got dissolved in acid. Here's some more twins, 2 times 2. This one gets out, that one gets dissolved in acid. 3 stays in jail. He has no twin to dissolve in acid. So when they get out, 2 and 9 get remultiplied together. 2 times 9 is 18. 3 is in jail. So x, our height, is 18 times the square root of 3. Now they wanted the area, so we put it into this formula. The area of a triangle is 1/2 base times height. Well, all the sides are 36, so the base is 36. And the height is 18 times the square root of 3. Multiply those together in your calculator, and you would get that the area of that yield sign is about 561.18. Or maybe that's exact. I think it was about that. All right, so that is special right triangles that I do not care if you learn about. I just want you to be good at Pythagorean theorem. And I'll teach you trig, and that's all you need to know. All right? Math is great. See you next time. We'll be working on learning trig soon.